We're doing an example which involves linear modelling. That means finding out the equation of a relationship which models a set of data. The first step is to plot the data on a scatter plot. So each point is represented by a dot or a little X on the graph. We're looking at the weights of a patient at a weight loss clinic over a series of months. So after 9 months, the weight was 128. After 1 month, the weight was 115. After 2 months, 118. Went up a little bit. After 3 months, 102. 4 months, 99. 5 was 87. And 6 was 82. Well, that's done what we call a scatter plot. The next step is to put a straight line through the graph as best we can. Now simply, don't go dot to dot with little straight lines. We want one straight line that best fits that data. Don't simply join the first point and the last point. I want the best line that you can fit through here. And what that actually does, it means minimising the total distance that the points are away from the line. Your line of best fit may not even go through any of the original pieces of data. Now it's very hard to do actually with a steel ruler, and a plastic ruler would have been a much better weapon to choose for this job. But I'm just going to put mine through here. Hopefully I've got it through as best I can. Obviously there is some sort of play in this sort of thing, and where you choose to put your line through may not be exactly the same as your neighbours, but by and large I think you can see that these points showed a general pattern of the weight loss going down, and I've tried to put mine through here so I'm minimising the distances that the points are away from the line. Now the next step is to pick 2 points on the line and then work out the equation which represents the joining of those 2 points. Now, the 2 points that I choose need not be original data points. They must be on this line we've drawn. And in fact, my line didn't go through any of the original data points, so I can't choose any of those. Choose 2 points on the line which are some distance apart. And I'm going to indicate them using a different indicator. I'm going to use a dot with a circle around it. And I've picked 2 points there. Try and get a bit of a distance between them. That helps with accuracy. And it's sometimes a good idea to write your 2 points on there. That will help you with errors later. This looks like to be the point 1, 122. And this point looks to be the point 6, 80, near enough. So those are 2 points on my graph. I'm going to now work out the equation of the line that joins those 2 points. I'll just move my paper up. That's better. So let's work out the equation joining 2 points can be found in 2 steps. First of all, we'll work out the gradient between those 2 points. And we'll do that using the formula y2 minus y1 over x2 minus x1. The difference in the y's divided by the difference in the x's. Now if this is my point x1, y1, and this can be my point x2, y2, then y2 minus y1 is equal to 80 minus 122 over x2 6 minus x1 1. 80 minus 122 is negative 42 over 5, which equals, I'll go to my calculator, negative, because we've got a negative divided by a positive, negative 8.4 is the gradient between those points. Now that I've got that, I can use the equation y minus y1 equals ax minus x1 to work out the equation between the points. So I've got y minus and y1 was 122, equals A is the gradient, negative 8.4, x minus x1 is 1. Multiply this out of brackets first, y minus 122 equals, and remember the negative 8.4 applies to both those things, so it's negative 8.4 times x, and negative 8.4 times negative 1 is going to be plus 8.4. Now to finish this off and get it in the form y equals ax plus b, I'm going to want to add 122 to both sides. So y equals negative 8.4x, and 8.4 add 122 is 130.4. Now that's the equation between those points. Now it's sometimes a good idea, it makes your equation a bit more understandable if you write it in terms of the original variables. Now on the y-axis I was graphing weight, so I can swap y for weight. I can even write it as a whole word if I want to. Weight is equal to negative 8.4, and on the x-axis we had number of months. I'll just write m. There's the equation. This equation will tell you the weight of the patient if you know the number of months. By substituting in any number of months, you could work out the weight.